Okay, I wrapped up last time talking about this inherent compromise in social psychology between internal and external validity. Internal validity having control, external validity having generalizability and realism. And one way that researchers sometimes will approach this compromise is by running a quasi experiment. So quasi experiments might be ways to use more realistic, naturally occurring groups rather than randomly assigning people to them. So, for example, imagine an educator wanted to test a method of teaching to their students, and they want to use, let's say, comparing an old method to a new method, and they had all these students. It might be kind of artificial to randomly assign different students to each of these scenarios, and maybe even teach them all independently using the old and the new methods. That would be really artificial in a lot of ways. It would be a high level of control, but it wouldn't be very realistic. Quasi experiments might be a good compromise to, give people a realistic sort of group setting without using actually random assignment. So maybe this teacher has two classes already, and they teach one section of the class with an old method, another section of the class with a new method, and then compare those naturally occurring groups rather than using randomly assigned ones. So like I've mentioned, this could be two different classes. It could be types of demographic or identity characteristics like males or females or socioeconomic status or where you live or something, or it could be things like your occupation. So any naturally occurring groups might be used in this way. And you just assign them like you would assign participants into different conditions. You just assign a whole group into a condition. So maybe psychology class A is getting the old method of teaching. Psychology class B is getting the new method of teaching. So there's not random assignment here officially. So you can't rule out some of those alternative explanations that, the groups are just different in and of themselves rather than the treatment. So these are not true experiments, and that limits how strong you can really argue for causal inference here. You can't necessarily say as clearly there's a cause and effect as you could with an experiment. Okay, I want to talk a little bit about different types of study designs here too. Um, what I mean by study designs are, the different factors involved in creating your study, like the number of variables and how they're assigned to different participants and things like that. So thus far, we've basically just talked about studies with one independent variable with two conditions, but studies can be much more complicated than that. Um, and when you are describing a study design, you might first note how many independent variables are there. Are they just looking at teaching style, or are they looking at teaching style and who the teacher is, right? That might be a two independent variable study. It's also very much possible to have more than one condition. Instead of just high stress and low stress, maybe you have uh, a control group, then low stress, then medium stress, and high stress. And you're comparing four different conditions on a single independent variable of stress. So you can have different numbers of variables, you can have different numbers of conditions for each of those variables, and you might expose different groups of people to these conditions in different ways. And I'll explain that a little more in just a second. So which people are being exposed to these different conditions is either a between subjects or a within subjects design. Between subjects design is the usual way that you hear people talk about random assignment, and it's really what true experiments are all about. Every participant is put in one condition, exposed to one level of an independent variable. So only getting the old method of teaching and then not getting the new one, or only getting the light condition and not the dark condition. A within subjects design is different. Every participant in a within subjects design is exposed to every condition. So let's say people would do the old teaching method and then the new teaching method. That introduces problems, of course, because if you've already gotten the old teaching method, then maybe it just looks like you're doing really well after you do a second new teaching method. So under certain circumstances, it's not appropriate to do within subjects design. But sometimes, if there's no bleed over or crossover between those different conditions, you might be able to do lots and lots of different trials with different variables, and they might not influence each other in that way. So between subjects, everybody gets one condition. Within subjects, you're making comparisons within individual subjects, and you are exposing everybody to every condition. And a mixed design is a mix of those. If you have more than one independent variable, you can expose some people to one, or expose everybody to one condition of one of your variables, and only one level of another variable. So I'm sure that is incredibly confusing when I only talk about it in abstract terms. So let me give you a few different examples. So let's talk about a research question. Are GRE prep courses effective? A between subjects way of testing that would be that you have a sample and you randomly assign every individual person there to either take a prep course or not. Take a prep course or prepare on your own. 2 groups. Then you compare the GRE scores of those 2 people. You're comparing between groups of subjects there. A within subjects design would be that you have basically like a pre-test and a post-test. You have people take a GRE, you collect those scores, you then have all of those people take a prep course, then take another GRE, collect those scores, and you compare those first scores to the second scores. And if you see improvement, then you might infer that the prep course is the reason for the improvement. Of course, it might just be that they've taken the GRE twice, so you need to sort of account for that. But if you have pre-tests and post-tests about different things, then it can be a useful within subjects type of design. To show this example with a mixed design, we kind of have to add another variable. So the example I have here, you have people take a GRE without preparation and collect their scores. You then randomly assign some of them to take a GRE prep course and some to prepare further on their own. Then you have everyone take another GRE and you collect those new scores and compare how much people improved and compare it between the preppers and non-preppers. So this kind of corrects that problem of the within subjects design. This is actually called I'm not going to quiz you on this, but a Solomon 4 groups design, where you have 2 groups that prep, 2 groups that don't, and you can kind of balance out the problem with that within subjects design there. I do want to go through just one more set of examples to kind of make this hopefully a little more clear after I talk about how you denote these things, basically. So the way you note a study is with as many numbers as there are independent variables, and then those numbers represent the number of conditions. So a 2x2 design, for example, you'll notice there are 2 numbers, 1, 2 numbers, meaning there are 2 independent variables. Each number represents 1 independent variable. Then the numbers themselves represent the number of conditions for each independent variable. A 2 condition independent variable, like let's say prep or no prep, by another 2 condition independent variable, let's say rest and no rest, or less rest. So you could look at the impact of prepping and how much sleep somebody is getting and how those things combine and interact with one another. This one, take a second for yourself. How many independent variables are there in this study? 3, right? There's 3 different numbers, so there are 1, 2, 3 independent variables. What about how many conditions does the first independent variable have? 3, right? The first number is a 3, so this first independent variable has 3 conditions. The second has 2 conditions, and the third has 4 conditions. So these things can get kind of complicated pretty quickly if you're adding independent variables. Okay, finally, I just want to show you how individual participants might be assigned to these, just to make sure that we're on the same page about how this assignment really works. So let's pretend that we have a research question about how much fun people have based on what type of game they're playing and how big their group is. So let's say we have groups of 2 versus groups of 4. That's our group size variable. And we have playing Monopoly versus playing Twister. You know, a natural comparison that you all make all the time. What's more fun, Monopoly or Twister? So think about it this way, that there are 4 possibilities. People might play Monopoly in pairs, Monopoly in a group of 4, Twister in pairs, or Twister in a group of 4. So how might those different combinations impact the level of fun people have? I mean, we'd have to test that, obviously, but how would people get assigned to this is more what I'm trying to show you here. Okay, so for a between subjects design, every participant gets assigned to only one condition. So let's say we have 12 hypothetical participants. That would be a very inappropriately small sample size, but let's say that's what we have for now. And we randomly assigned each of these people to one and only one condition. We might end up with something like this, where you have participants 4, 6, and 10 happen to be the people that are in the Monopoly and pairs group. And 5, 7, and 11 are the people who are in the Twister in a group of 4 condition, right? So this is a completely between subjects design on both of these independent variables of group size and Monopoly, or group size and game. You even notice that nobody that's in the pair group is in the 4 people group, and nobody that's in the Monopoly group is in the Twister group. It's along all these different axes, nobody is repeating a condition. Okay, what if we did a within subjects design, where all participants are assigned to all conditions? This is a little more straightforward, right? Everybody does everything. All 12 people do Monopoly in pairs. All 12 people do Twister in pairs, and so on and so forth. Everybody does everything, and then you can compare within subjects the differences in the level of fun that they have. Great. What about a mixed design? Let's say for our purposes, we want to do within subjects comparisons for group size and between subjects comparisons for game type. Okay, if we did that, we have within subjects comparisons for group size. So the same people are doing different group levels. Monopoly for these 6 people compared to Monopoly for these 6 people in these different group sizes. But we're doing between subjects for game type. So these 6 people are assigned to Monopoly, and these 6 people are assigned to Twister. It's repeated measures on group size and between subjects on game type. So hopefully this makes it a little bit clearer. I know it's a lot of information. That's why I try to explain it like 3 different ways, because I think people have trouble with this sometimes. So feel free, follow up with questions. I know this can be a little complicated, and I'll wrap up in the next video with some stuff about replication and reproducibility.